Hello, everyone, and welcome. If you're an ambitious, focused learner ready to turn all that theoretical knowledge into real-world skills, well, you're in exactly the right place. Today, we're unlocking the absolute secrets to mastering the Cognifyz Machine Learning Internship together. We're going to break this fantastic program down step by step. By the time we're done here, you'll know exactly what you need to build, the core machine learning concepts you're going to master, and exactly how to secure that internship certificate.
Okay, let's dive into our roadmap. First up, a quick welcome to the internship. Then we'll explore the restaurant dataset, tackle the regression and recommendation tasks, move right into classification and location analysis, run through your ML toolkit, and finally wrap up with submission and success tips.
All right, Section 1, welcome to your ML internship. Let's get right into it.
So, this internship, it's entirely project-based. You'll be using one unified restaurant dataset to learn real-world concepts. But honestly, the absolute most important number you need to remember for your certification is 3. You do not need to do all 4 of the available tasks. No way. To successfully complete the program, you only need to tackle any 3 out of the 4 machine learning tasks we're about to cover. This is huge because it gives you the flexibility to focus on the areas that actually interest you the most, while still building a rock-solid foundation in machine learning.
Moving on to Section 2, exploring the restaurant dataset.
Look, before you even think about writing a single line of code, you have to understand your data. Looking at our features here, we've got geographical info like city, country, latitude, and longitude. We've got business specifics like the restaurant name or if they offer online delivery. And then we have the really juicy stuff for machine learning: cuisines, price range, votes, and the aggregate rating. These features are essentially the raw materials you're going to use to build your predictive models. Trust me, understanding the shape of this data, finding the missing values, and grasping what it all means, that is exactly what separates a good data scientist from a truly great one.
Which brings us to Section 3, regression and recommendation tasks. Let's look at the first 2 core challenges.
Task 1 is all about regression. The main objective here is to build a regression model that actually predicts a restaurant's aggregate rating based on its other features. Why regression? Well, because we're predicting a continuous numerical value, a rating. It's like a giant puzzle. You'll start by pre-processing your data, handling any missing values, and encoding categorical variables so the computer actually gets it. Then you split it into training and testing sets. You're going to train algorithms like linear regression or decision tree regression. But it doesn't stop there. You have to evaluate your success. You'll use metrics like mean squared error and the R-squared score to see just how accurate your predictions are, analyze what features matter most, and figure out how to dial up that performance.
Now, if you choose Task 2, you'll be building a restaurant recommendation system. The goal is to create a system that suggests restaurants based on user preferences, taking in data like their favorite cuisine or price range. You'll clean that data up and use techniques like content-based filtering and similarity calculations to build out the logic. Think about it. This is exactly how Netflix suggests your next binge watch, how Amazon recommends products, or how Swiggy suggests your dinner. They're using these exact same foundational recommendation logics every single day. You're going to build this, test it out with different users, and work on refining that recommendation quality.
All right, on to Section 4, classification and location analysis. Let's see how this builds into the remaining 2 tasks.
Now, what's really interesting about this slide is the direct contrast between these core machine learning concepts. In Task 1, regression, your model is trying to spit out a specific number, right? Like a rating of 4.2 or 3.8. But in Task 3, classification, your model is trying to output a specific category. It's asking, is this restaurant Italian, Mexican, or Indian? Grasping this fundamental difference between predicting a number versus a category is a massive leap forward in your machine learning education.
And that leads us perfectly into Task 3, Cuisine classification. The objective here is to build a multi-class classification model to identify a restaurant's cuisines. You'll start with data pre-processing and label encoding, then hit that train test split. The algorithms you'll deploy this time are logistic regression and random forest. And because this is classification, your evaluation metrics completely change. Actually, scratch that. You won't use mean squared error at all anymore. Instead, you'll evaluate your model using accuracy, precision, recall, and the F1 score. Plus, you'll learn to use a confusion matrix, which is incredibly cool for visualizing exactly where your model is making correct predictions versus where it's getting, well, confused by the multi-class challenge.
Task 4 is location-based analysis. For this one, we step away from predictive modeling for a moment and dive deep into geographical analytics. Using the latitude and longitude data, you'll analyze restaurant distribution, run city-wise analysis, and spot average ratings and cuisine trends across different locations. You'll compare prices and lean heavily into data visualization. Honestly, this brilliantly illustrates the real-world value of data science. By mapping these trends, you can find incredibly actionable insights. You could literally help a business decide the absolute best, most strategic location to open their next restaurant based purely on this geographical data. A real game changer.
Next up, Section 5, your Machine Learning Toolkit. Let's look at the tech stack required for all this. To actually write the code and train these models, here is a rapid-fire rundown of your tech stack. Python is your foundational programming language. You'll be coding in interactive environments like Google Colab or Jupyter Notebook. When it comes to handling and cleaning that data, Pandas is your best friend, while NumPy handles the complex numerical calculations. When you need to visualize the data, which is absolutely crucial for Task 4 and super helpful for all the others, you'll use Matplotlib and Seaborn. And finally, the whole shebang is powered by Scikit-learn, the powerhouse library that provides the actual algorithms for your regression and classification models.
Finally, Section 6, Submission and Success Tips. Let's get you that certification.
You've done the hard work, so let's guide you right across the finish line. To make sure your hard work is properly evaluated, follow this step-by-step administrative workflow very closely. First, per the onboarding guidance, you must complete at least 80% of the assigned work for your chosen 3 tasks. Second, meticulously organize your source code, notebooks, any trained models, and your documentation. Third, compress it all into one single zip file. And fourth, upload that zip via the official submission form before your deadline. Keep in mind, projects are evaluated on accuracy and completeness. Oh, and just a quick note, according to the instructions, submitting a project demonstration video is purely optional.
As we wrap up, I want to leave you with some final mentor advice for truly standing out. Always read the dataset before you start coding. Clean your data carefully. Remember, garbage in, garbage out. Visualize your data before you train any model so you actually understand the underlying patterns. Don't just settle for the first algorithm you try. Compare multiple machine learning algorithms to find the absolute best fit. Crucially, document every single step in your notebook and clearly explain your results and conclusions. And it goes without saying, but avoid plagiarism. Write your own completely original code. Doing these things will ensure you build incredibly strong ML skills.
We've explored the entire Cognifyz Machine Learning Internship, from understanding the restaurant dataset to predicting ratings, classifying cuisines, and mapping geographic trends. The tools are right there in your hands, and the path to earning your certificate is totally clear. So I'll leave you with this provocative question to spark your ambition. Which 3 of these 4 tasks will you conquer to build your machine learning foundation? Dive into the code, trust the process, and I wish you the absolute best of luck on your internship journey.